Hey guys, so I'm creating my own context-aware chatbot. Um, I'm on this Ollama Docker image, and which I am getting right now. So the goal is at the end to make a chatbot that could help us with the data of tipcity.com. So that's the goal. Let's see what we can do and what we cannot, because I have no idea how it works. But that's how it works. Like you have no idea, and then you start doing stuff, and you get some idea. So that's what I'm doing. Um, let's see. So I'm pulling up this image, Docker image. Uh, Let me go to YouTube. Uh, YouTube Studio, content. Please do subscribe. Uh, oh, Ollama, Docker. mm, Deep Seek R1. This is not an easy thing that I'm doing right now. I'm not choosing the easy path, I'm choosing the harder part. So be mindful of that. And okay, doesn't seem like it will download very fast. But we'll wait. We'll explore till then. Go to the Discord channel. Ollama. This is Ollama Discord. Welcome to Ollama website. Nice. Very, very Discord. Cross channel. Cross. Very basic. I like these basic Discord channels. There's some kind of rawness to it that I find very fascinating. Do I have my Docker images? No. It will take time. It will take time. Going on my whole channel. Yep, I have it all. Let's quit. VS Code web programming. Ollama, 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 Ollama. Ah, 677. So, how does Ollama work? I want to figure out Ollama APIs. Okay. Ollama run, which will run the model, customize the model. What is GGUF? GGUF, a binary format. Okay, it's the model. Okay, it's the Hugging Face model. Okay, okay. Okay, I think I know some bit. I don't think Ollama will help me a lot. Uh, Not the way I would want to go. This is all fine. Uh, how do I make multiple user use a model? And that is the problem. I can spin up a new model when a new user comes, or like I can have two models when there's one model. Then at that point, like, I can have multiple models, but whatever. AWS. AWS gotten much prettier looking. This is the old AWS I'm used to. Function calling. How to make an AI agent. AI agent will solve my problem.
यहाँ पे एरर इसलिए आ रहा है
Okay, let's do this.
console.log डालते हैं, ठीक है?
is raging about
So,
AI agents.
hey everyone, welcome back. Welcome to another exciting video. And इस वीडियो के अंदर हम बनाने वाले हैं खुद का एक AI agent
Right now. Yet some of the biggest companies like Apple and Amazon
Hey
still
everyone,
struggle
welcome
to
back.
ship effective AI features within their products. Last week, Apple had to pull back Apple Intelligence because it was hallucinating in the new summarizations that the product was providing. And also, Amazon still struggles to put AI features into Amazon Alexa because of the hallucinations. Yet, if you look online on YouTube blog posts, everyone seems to be building these AI agents, and everyone has their own ideas and tools and frameworks on how to do so. But here's the hard truth. Building effective and reliable AI agents is really hard. And most of the examples that you will see online are really cool demos, but they are just that. They show what's possible. They show where the future is going with AI agents. But if you really put that into a product and let a lot of people use it, it will just simply break down. Now, in this video, I want to share some practical tips and techniques for developers to build more effective and reliable agents. Now, while I definitely don't have all the answers here, I'm going to share some of the lessons that I've learned over the past 2 years building AI systems. I'm the founder of Data Lumina. I hold a bachelor's. And next to that, I also run a community with over 100 freelance data and AI developers. And I make these videos to help you level up and become a better engineer. And depending on who you ask, you are going to get a very different answer most of the time. And that is because a lot of people have different ideas about what they are. And if right now you'll search for how to build AI agents online, you'll find some tutorials, almost all of the tutorials that you'll find where they talk about AI agents. What they simply mean is you have some piece of software, you have some operations where at some point you're going to make an API call to a large language model. But now, is it really fair to say that such a system can already be called an AI agent? Well, if you ask the experts, the answer is no. Yet why is then everybody talking about AI agents like they are just that? Well, that is simply because there is a lot of hype and a lot of buzz around that particular word. Everyone wants to use some Illumina as AI systems rather than AI agents, where not all AI systems are necessarily AI agents. And now to make this more clear for you, throughout the rest of this video, they talk about first how a lot of people have a lot of different ideas about it, but then at Entropic, they make a clear distinction between workflows and agents, where workflows, quoting, are systems where LLMs and tools are orchestrated through predefined code paths. So this really aligns with what I was saying previously and what you'll often find online, where you have a certain system, some steps, some change, and at some point you make a call to an LLM. Now, agents, on the other hand, are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish the task. So there's a clear distinction between the two, between workflows and agents. And as a developer, it's crucial to understand when to use which pattern. And because of all the tutorials and information out there right now, where everyone is using the word agents, thinking that you need all kinds of tools and frameworks in order to build agents, there's a lot of confusion. If we then come back to Entropic's blog post and to the section when and when not to use agents, and in my opinion, this really hits the spot. So as a developer, consider the following. When building applications with LLMs, we recommend finding the simplest solution possible, something you should always do as an engineer, and only increasing complexity when needed. This might mean not building agentic systems at all. And here's the thing, for many applications, however, optimizing single LLM calls with retrieval and in-context examples is usually enough. And we've been building AI systems for our clients across industry since the day the ChatGPT API came out, and I can definitely tell you this is true. For many applications, you don't need these agentic patterns. You can build predefined simple workflows that solve a particular problem really well, and then create a suite of tests and evaluations around it to really keep it in control and to really optimize it over time. Okay, so then how do you actually build effective AI agents, or rather AI systems, I would say? So the first step for you as a developer is really deciding on what you are going to use to build your AI system. Now, if you have coding skills, you probably want to use something like Python or TypeScript or even JavaScript. And if you don't have coding skills, you probably want to look at something like Make.com, N8N, or Flowwise. And it doesn't really matter what tool you use. Like if you do full coding or use these workflow builders, which they essentially are. In both cases, you can build reliable systems. It's much more about the underlying patterns that you use to control the flow of your application and your data. So that's what I want to dive in right now. Coming back again to the excellent blog post from Entropic, where they outline some of the different patterns that you can use to build applications around large language models. So here are some of the common building blocks that you can use when building AI systems, whether that's workflows or agents. And the basic building block that we all start with is what they call the augmented LLM. So we start with an LLM, a simple API call in the beginning, and we can augment that, we can enhance that by focusing on three things. The first one is retrieval. retrieval, then we have tools, and then we have memory. Starting with retrieval. This is where your AI system pulls information from a different source, typically a database or a vector database, and makes that available within the context of the large language model. Now, in practice, typically this is done through retrieval augmented generation, or RAG for short, using a vector database where you perform a similarity search on. People often compare this to giving your LLM application long-term memory, because you can essentially offload all of the relevant context that you need to a vector database, and whenever the LLM needs it, you can try to retrieve it. And I'm saying try because with retrieval augmented generation or RAG, you never truly know what you're going to get back, especially as the scale of your database grows. So the second augmentation of LLMs is what they call tools. And tools are essentially little services or APIs that you can call within your application in order to get more information. This could be, for example, making an API call to get the current weather data or to get the latest shipping updates on your parcel using the tracking number. And then the last part here is memory, which in this context simply refers to the past interactions that you've had with the LLM system. So you can think of this, for example, when you're talking to ChatGPT, every time you send or ask something to the model, that is then a new record. The model will then respond. That is a new record. And the whole chain, the whole sequence of all of those interactions together is what you call the memory. So these are the three common concepts that you'll encounter when you're working with LLMs and creating these agents in order to make the API call to the LLM better. This is all about enhancing the context, providing more context in order to get better results. And when you combine these three and put them together in perfect harmony and in sync, they take your application beyond just being a simple OpenAI or ChatGPT wrapper and really taking your app or automation to the next level just because you can get all of the right context at the right time. All right, and then up next, let's look at a pattern that you can use to build very effective workflows. And often this is all you need. And this is called prompt chaining. So this is simply just chaining together multiple calls to an LLM and typically using the previously generated information and then passing that to the next LLM call within the sequence. And in this way, you can break down a complex problem, and instead of asking the AI, write a blog post, you can break that down to first do some research and get clear on some ideas, then dial in on a specific topic, then provide an outline of what the essay or blog post could look like. Then give me all of the different chapters. Now write chapter 1, now write chapter 2, and every one of those steps could be a chain within the whole application, where at every step you now have more control, because at every step there's data and a prompt that you control and can tweak. And this is guaranteed to improve your application and to make your system smarter overall. All right, and then let's get into the second pattern, routing. So while prompt chaining can already get you great results if you focus on a single problem, if the scope of the problem that you're trying to solve grows bigger and there are multiple scenarios, multiple cases, multiple solutions, that is where routing comes in. And what you essentially do with routing is, given all of the data and context that is coming in, you let the LLM decide which way to go. And you could clearly instruct the LLM for the first step to categorize the incoming requests. So is it A or is it B? And we then capture that in a structured way, so then within our application, within our control flow, we can use the so-called routers, which in theory are practically just if statements or cases where we make a certain match, and if output equals A, we so that is routing. And then real quick, if your device then goes into a particular direction, and if the output was B, for example, we go in a different direction. So that is routing. And then real quick, if you're a developer, you got some technical skills, and you've been thinking about starting as a freelancer, maybe taking on some side projects to make a little bit extra money or learn more, but you don't really know where to get started or struggle to land that first client, you might want to check out the first link in the description. It's a video of me going over how my company can help you with that. We have a community with over 100 freelance data and AI developers, and we're all here to make more money, work on fun projects, and create freedom. So if that's something you're interested in, you might want to check it out. All right, and the third workflow pattern is parallelization. And with parallelization, you also make, similar to a prompt chaining, you make multiple LLM calls, but rather than doing them sequentially, where one output might depend on the other one, you do them in parallel. And this is ideal for where you can really split up a certain task, break it down, but they are independent of each other. And this can help you to speed up your application, because the output would be the same if you sequence them sequentially, but then you need to make multiple API calls and wait for that to finish, then do the other one, do the other one. Parallelization is a way to do this async. Accuracy or correctness will be done in parallel. It could then come together, and that could act as your guardrail system. All right, and the next pattern is the orchestrator worker. So this is still a workflow pattern, but this already gets a little bit more agentic because it requires a little less explicit programming of steps, but it's still sequential and linear in nature, and therefore also really predictable. The customer is coming in, and you let an LLM look at all the context. So the customer, and then ask an LLM what's required in order to solve this particular problem. And the LLM might decide, okay, we need to look up and assess the right section within the customer care playbook. We need to do a lookup of the particular order to check the status. And we also need to call the shipping API in order to get the latest shipping information. Through this pattern, we can make our application already more agentic and have less hard-coded pathways in there. All right, and then the last workflow pattern is the evaluator optimizer. And this is simply where you let an LLM create an output and then feed that into another LLM call to review it and give feedback, and then pass that to another LLM to improve that. So you could say, write a blog post. You have the blog post. Then you have another prompt that says, critically review this blog post and make sure it adheres to X, Y, Z, a whole list of things that you would like to have there. Then